Welcome back to my YouTube channel, Steve Learning Note. In this video, we are going to learn about OSI model. OSI is Open System Interconnection Model, which one of the standard for network communication created by ISO organizations. In this video, we will learn about OSI layers, examples, OSI model across networks, and we will summarize by finding out why we need this model. OSI model has 7 layers. 7th layer, applications. It manages interface to access network resources. In these layers, it can use several protocols like HTTP, HTTPS, gRPC, SMTP, Telnet, and etc. The 6th layer, presentations layer, it manages data encoding, serializations, and compressions. In the 5th layer session, it manages the connections and then the sessions. In the 4th layer, transport, it manages end-to-end communications between applications. In this layer, we usually use TCP or UDP protocol. In the 3rd layer, network, it finds the best path to send data across network with using IP protocol. In the 2nd layer, data link, it controls communications between devices on the same local network. Here we are going to use Ethernet, MAC, and also frames. And last but not least, physical, it moves raw bits 0 and 1s through cables or wireless signals. So between layer 7 and layer 2, all of these layers are logical layers. Nothing here is actually physical until layer 2. And then layer 1 that does the conversions into something physical that actually we can send over the wireless signals or through cables. So let's see the example for a better understanding. Here, example of sending a post request with HTTPS endpoint with JSON body from sender point of view. Because it's from sender point of view, the directions will be starting from the layer 7 to layer 1. It begins by the application sending a post request with HTTPS protocol, of course with the JSON data. And then in the presentation layer, it serializes the JSON into the byte string, and then TLS encrypts the request and data is compressed. In the layer 5, it establishes TCP connections and TLS sessions between the clients and then the servers. And then let's say it's the first time try to connect with the server. So therefore it sends a SYN request, right? The three-way handshake in the TCP protocol to the port 443 because it's TLS, right? The default port is 443 to the target to initiate the connections. The encrypted data is broken into segments and each with the source and destination port. So the data that is serialized and encrypted here will be broken up into multiple segments. And in segment, it will be stamped with a source and destination port. Right? The destination port here is the 443, and the source here is the port used by these applications. And in the network layer, each segment will be an IP package. So each IP package will have its own source and destinations IP addresses. And then in the data link layer, each package is placed in a single frame. And each frame will have resource and destination MAC address. And then finally, the frame is converted into physical signals. Electric signals on the copper cables, like pulses on the fiber optic cables, or radio waves if we use Wi-Fi, right? So from 7th to layer 1. So meanwhile, from the receiver point of view, because it receives, it's set from layer 1 to layer 7, right? So the direction will be down, up. So it receives the signals, right? And then convert it into digital bits. The signals converted back to frames, and then the MAC address will be checked here. And then after that, the IP address from the IP package will be checked, right? Here the routing decision will be made, right? Like if it's a request for me or not, right? And then the transport layer, the TCP segments reassemble in order. In the case of a SYN request, actually we don't need to go further into the upper layers because we are still processing the connection request. Therefore, it will go back to layer 3 to 1 and then send the response back to the sender. But if the TCP connection has been established, it will be managed by the session layer. And then in the presentation layer, data will be decrypted using the session keys. And then the byte string will be deserialized back to JSON object to be used by the applications, where it will receive the post request and do whatever logic that it has there, right? Yeah, so here we have client and server. So applications send the request, right? The request will be deserialized. Will be serialized and then encrypted. And check the session if there is a session there already or not, right? And then data will be breaking that into segments, and then we'll assign a destination and source port. And in the network layer, it will be converted into IP package, and each package will have source and destination IP, and then goes to data link where it becomes frame, and each frame will have source and destination's MAC address, and it goes to physical layer, transmit to the servers, right? Then the server will receive to data link network transport stations, right? And presentation applications. In reality, between client and server, actually there will be devices and services, right? So for example, if we have configured switch, right? If our request go to the switch first, switch need to forward the request based on MAC address, because it needs to know the MAC address of this request. It needs to pick, right, the request until the layer 2 of the OSI model. So switch is a layer 2 OSI device. If we have router, and I think there will be so many routers, routers need to route based on IP address. Therefore, router is a layer 3 device, because layer 3 is the network layer, right, where the IP address is. How about we have proxy, right, like firewall. So for firewall, it needs to block, let's say, or filter based on IP and also port, usually, yeah. Common firewall, right, blocked by IP and port, because it needs to know the port. It needs to pick until layer 4, right? It needs to know the port. It needs to know the IP and then the port, right? So until this layer 4, right? Anything here is publicly available. Like we can actually see, right? But in order to see and understand layer 5, 6, and 7, we need to have the session key, right? We need to be able to decrypt, deserialize, decrypt the messages, right? The requests, where not all device or service has that capability. So that's okay for devices to check until layer 4. Let's say this is a proxy firewall. What if we have load balancer or CDN, content delivery network, right? In order for load balancer or CDN works, it needs to know, usually, the URL path, right? If it needs to load balance based on the URL path, and CDN definitely it needs to know the URL path because it cache based on the URL path, right? Based on the URL path and based on the header. So CDN definitely is the layer 7 services, and some of the balancer is also a layer 7 services, right? So for this client, this reverse proxy is the final destination, right? But actually, the final destination of the request is the actual backend that resides behind the load balancer or the CDN here, right? So the request, you go up here until the 7th layer and then return back to the actual server. So the latency here will be slower compared with the firewall, compared with the router or the switch or the router or the switch. Why? Because there are 7 layers need to be accessed, right? Way slower. So network devices by OSI layer. So we have seen this before, but let me just summarize. We have switch, which is layer 2 device, because it is MAC address to forward. And router is layer 3 device, it needs IP for routing. ISP. So ISP, they can route our request, right? So usually ISP is a layer 3 services. Firewall, right? It uses IP port filtering. So it will be the layer 4, 3, or 4 services. But in a modern firewall, they can filter based on the content. So it needs to inspect the content. So it will be the layer 7 services in that case. How about CDN? Yeah, CDN is layer 7 because it's a content aware caching. Load balancers, right? If we need to load balance only based on IP and port, it will be layer 4. But if we need to distribute the load based on the content or the URLs, it will be the layer 7 application or services. How about VPN? So most of the VPNs works in the layer 3 or layer 2, mostly in layer 3. What it does, it will encrypt our IP package, right, which is in the layer 3, and then tunnel with their IP package. So that is the network devices by OSI layer. So this is the final slide, why we need the OSI model. Separation of concerns. Each layer solves one problem independently. Changes in one layer don't break others. For example, if we have web applications running, right, using Node.js, connecting with Wi-Fi, and then someday we want to change it with fiber optic, it will not break our applications. Technologies can evolve independently. Yeah. So let's say IP. IP can evolve from IP4 to IP6. HTTP, the versions can evolve from 1.1 to 2 to 3, right? The physical layer can evolve, right? From the Cooper cable to fiber optic to Wi-Fi, right? Separation of concepts. Next, interoperability, right? OSI is a conceptual model not tied to specific vendor or protocol. It means our app can run in any programming languages. If we use TLS, we can use any kind of any kind of libraries. We can use any kind of kernel, Linux kernel, or if you use Windows or if you use Mac, right? It will be handled by its TCP implementations. We can have different network cards. It doesn't matter of the vendor or protocol. It will works. It can still be logically compared because OSI is a conceptual model. Simplifies networking, right? Networking is complicated indeed, and this model helps us to understand what's going on inside by breaking the complexity into manageable layers. And then let us learn and reasons about one layer at a time, which is comes to the last reasons where something goes wrong, right? It helps us to systematically narrow down the problem. If our web application doesn't work, right? Maybe we can check from the 7th layer first if the web server is responding or not, right? Oh yeah, it's responding. It doesn't have the errors. And then we go down to layer 4 if the TCP connection is established. Go down to layer 3 if the IP address is assigned correctly. Go down to layer 2 if the network interface is up and running. And finally, if the internet, right, the Wi-Fi is connected or not, is working or not. Yep, so that's it about the OSI model. I hope you enjoyed. Until the next video, keep learning and stay healthy. Goodbye.